Hey, algebraics, time for something new today. Today we're looking at the coordinate plane, as our mildly excited dinosaur wants us to know about. Of course, he's growling as usual, and of course, he's keeping it positive, and so are we, because we love math. Yay, math! The coordinate plane. What's the coordinate plane all about? You've seen this before. You've seen a graph before. You've probably seen this, but so hopefully it's a review to you. But if not, let's all get on the same page right here. This is what we call the coordinate plane. Let's get some terminology here. What makes it a coordinate plane? Well, we have two dimensions. We have a graph with two dimensions and two axes. The axes are these black lines in the middle right here. Right now, I am tracing in green what is called the x-axis. So that is the x-axis. That is also known as the horizontal axis. It is the x-axis, and really you can think of it as a number line. And we can label these, in fact, 1, 2, 3, 4, 5, 6, 7. We could go on into infinity. Here we have 0, and we could go the other way, negative numbers. And we could label this as far as we wanted to. Okay, that's the x-axis. Now you probably know where we're going with this, and I am now outlining the vertical axis, also known as the y-axis. So this is the y-axis over here, and this also is just like a number line. 1, 2, 3, 4, 5, 6, 7, and we can essentially think of the coordinate plane as two perpendicular number lines. It would also be 0 in the middle, and then it would count down to negative infinity. And that's going to be really helpful for us when we get to plotting points in just a minute. All right, so we have the axes, we have the x and the y. Now, where they cross is a very special point. So where they cross, where they're both 0, 0, that is called the origin. So if we're talking about the origin of the coordinate plane, we're talking about the point 0, 0, 0, 0. The point 0, 0 also kind of looks like a weird face right there. We draw some hair and some arms. All right, we're getting off topic, so let's get back to it. We'll erase our badly drawn graph man right there and get back to this. Okay, now you'll notice that when the x and the y-axis intersect, we actually end up with four, it kind of looks like four boxes here, and those have names. Those are called quadrants. So make sure you know what the word quadrant means. Quad means four, right? So we have four different quadrants, and actually they have labels. This is quadrant 1, quadrant 2, quadrant 3, and we use the Roman numerals, and quadrant 4. Quadrants 1, 2, 3, and 4. And those are just ways for us to quickly identify which part of the graph we're in. It's also interesting to notice what the signs of x and y are in each quadrant. So for example, if you were plotting a point, let's change to a different color here, in quadrant 1, can you tell what the x and y points would be? Well, notice as we're in quadrant 1, say I'm right here. That point, if we look at it just on the x number line, that is point 2. We would go over 1, 2, and for the y, it's up 1, 2, 3, 4. So we call that point 2, 4. And notice, both are positive. So if we're plotting in quadrant 1, our points are both positive. Now what would happen if we plotted in quadrant number 2? Let's say our point, let's plot the point 3, negative 3, 2. Well, these are called ordered pairs. That's actually another thing we need to know. We'll get to that in a second, an ordered pair. Negative 3, 2, we would start at the origin, and we count 1, 2, 3, and then up 1, 2. And that would be our point right there. And what is the sign on that? Well, notice in quadrant 2, it's negative and then positive in the y. We always plot x and then y in our ordered pair. And you could figure out the rest of the way. You know, if you were in quadrant 3, it would be a negative and a negative. And then in quadrant 4, you would have a positive and a negative. And that would let you know instantly that you were in quadrant 4. So to recap, the basics about the coordinate plane, we have the x-axis, we have the y-axis in red. We then have the origin. Right here is the intersection of our x and y-axis. That is the point 0, 0. The origin is the point 0, 0. We then have quadrants 1, 2, 3, and 4 as we go counterclockwise, starting with the positive, positive. We know the signs of the coordinates in each one. Now, I plotted some here, got a little bit ahead of myself, but know this also, the term ordered pair. Ordered pair. An ordered pair is a coordinate. It's a way to put a point actually on the graph. So let's just go for this pair. Let's say this 4, -1. So let's look at that first of all and think, which coordinate would that end up in, or which quadrant? Well, it's positive and then negative. It's also always x first and then y second. We always do our ordered pairs are always x, y. And it's positive and then negative. So where do we have x positive, y negative? Yeah, we're going to be down here in quadrant 4. So let's plot that. Let's go 4 on our x number line on the x-axis. So let's count from we always start at the origin. We go 1, 2, 3, 4. And then since it's -1, we go down 1. And that would be our point right there. That would be 4, -1. All right, so that's an example of an ordered pair. All right, let's check out a couple more of these. Some examples right here. We're asked to plot each point in a coordinate plane. So we're thinking about this. We're a very good student, so we got our hand on our head. We're stroking our chin, thinking, what do I do? And then we remember, ha ha ha. I have some great notes on this that I've been taking, right? You're taking notes on this stuff, and we'll check it out in class tomorrow. But let's plot these points right here. Point A. Let's get point A onto our coordinate plane here. Point A is 4, 2. So both are positive. So where does that have us end up? Yeah, over here in quadrant 1. Quadrant 1. So if it's 4, 2, then we go 4 in the x direction and then 2 in the y direction. So let's start in the middle. What's our middle called? The origin, right? Start at the middle in the origin, and we go over 1, 2, 3, 4 in the x. This is the x-axis. It's usually helpful to label these. This is the y, and then up 2. So that would be our point 4, because if you want to, it might even help you to do this. Label your number line here. We go over 4 and we go up 2, and that will be point A right there. Good. Okay, let's do point B. Point B is 6, 3. Which quadrant are we going to be in? Quadrant 1, good, because they're both positive. We have x is 6, y is 3, so we go over to 6. And then if we start counting up here in our y, let's label those. We will go over to 6 and up 3, and right there is point B, also in quadrant 1. Good. All right, now let's go to C. C over here, it's negative, negative. Where are we negative and negative both times? Well, we haven't labeled our negative side yet, but we know we're going to be in the left for the x. What about for the y? Well, for the y, we're also going to be, well, not also, we're going to be down below the x-axis for the y. That's where we are negative. So what is that quadrant? You remember? That is quadrant 3, where we are negative, negative. So let's see, we are at -4, -2. That is always the x value first, and then the y. So we start at the origin, we count 1, 2, 3, 4 to the left, and then down 1, 2, and that is C. All right, we will then do D. X, y, we're negative, negative. So we are in quadrant 3, and we will count over to -5. So I find up on my x number line, and I go down 1 in the y, and there is point D right there. All right, so you should be getting the hang of this pretty soon. 5 and 6, throw in something a little different. So let's look at 5 and 6. We'll switch to blue. Notice that we still always have the x value and the y value, but what's different here for 5 and for 6? Look at them. They look very similar. But notice we have a 0. We have a 0. So will this actually be in a quadrant? That's the question for us. Will it be in a quadrant? Well, let's check. Let's go to the origin, and let's count over -5 in the x. So start at the origin, and now I'm counting in blue. So 1, 2, 3, 4, 5. And here I am at -5. Now 0. So I can't go up or down in the y. So I'm not actually really in a quadrant right now. I am on the x-axis. This point E is on the x-axis. So what do you think about point F? Which axis will that be on? Well, let's count it. We're at the origin, and I go 0 in the x. So I don't go positive x or negative. I just stay right there on the y-axis. And in this case, I count down 1, 2, 3, 4 to -5, and I am not in a quadrant. I am on the y-axis, and that is point F. All right, well, 2 more to go. Let's switch up our color, and let's do G. Our x and y, we are -3 and 2. So where are we negative in the x and positive in the y? Well, that would be quadrant 2 right here. We're negative in the x. So let's count over. Start at the origin. We go 1, 2, 3 to the left because it's -3, and then up 2, and there's G right there. All right, one last point. It's point H, number 8 right here. Our x and our y, we are positive in the x, negative in the y. That places us in quadrant 4 in the bottom right, and we go over 1, 2, 3, and then down 1, 2. We plot point H right there. So you should be a master at plotting points right now, and you are just busting with ideas and ready for the next section. So here we go. Here's our last example. In this example, we are not plotting points. We were asked to read points off the graph and distinguish some information about them. So let's refer to the diagram at the right, and let's name the points that are described. So number 9, the point on the positive x-axis. Well, let's look at our diagram over here. Let's label our origin right here, and let's remember this, and they've actually got a label for us already, but I will make it really clear that that's our x in the horizontal, and then up and down there is our y-axis. And they're saying the point on the positive x-axis. So what do they mean by that? Well, when we start at the origin, remember it's like a number line. So if we count to the right, this way, we're getting more positive. So that is the positive x-axis. If you want to, sometimes people even label their graphs like this, and they'll say this is the negative x, and this direction is the negative y. That might be helpful to you, so that anything to the left of the y-axis will be the negative x. Anything to below the x-axis will be the negative y. All right, so the point on the positive x-axis. Well, we need to be on the x-axis, and look, there's only one point, and that is point Z. That is point Z. So how about the point on the negative y-axis? Well, we start at the origin. We're not on x. We just go straight down, and we look along here somewhere, and oh, in the negative y, it would be point G. Point G is the point on the negative y-axis. How about points on the vertical line through Z? The vertical line through Z. Interesting. So that right there asks us to find point Z. All right, so let's go a different color. Point Z, right here, I'm in green, making that big point, and they want to know what are the 2 points on the horizontal line that go, on the vertical line, excuse me, that go through Z. Well, if we drew a vertical line right there, through Z, there are 2 points. Can you name them? A and P are the 2 points. So similar to question number 12, the points on the horizontal line through Y. Let's find Y. Let's draw a horizontal line, a horizontal horizon, if you forget if that's up or down, or left or right. Horizontal line, and those 2 points through Y, you can see are going to be K and A. All right, now we want to know the x-coordinate is 0. So any points where the x-coordinate is 0. Well, where is the x-coordinate 0? Well, if we start on the x and we count left or right, then say I start counting to the right. That would be 1, 2, that would be increasing the x. So we want it to be 0. What about left? No, that gives me negative. So I need to be somewhere actually on the y-axis. So what points are that? Well, it turns out y, where x is 0, it would be y, and it would be g. So y and g. And how about where the y-coordinate is 0? Where is the y-coordinate 0? Let's look to the right and to the left, because that is the x-axis, and y, if we count up for y or down, then we have a value for y, it's not 0. So y is only 0 on the x-axis. So that would be v or z. So that's interesting. Make sure you realize that where the x-coordinates are 0 on the y-axis and the y-coordinates are 0 on the x-axis. Maybe pause and make sure you understand that for a second. Okay, 2 more. Where do the points have equal x and y coordinates? What points have equal x and y coordinates? that means that they are the exact same. Well, where can that happen? Well, let's count our quadrants again. Here's quadrant 1, remember? We start in the upper right and we count counterclockwise. We would, oh, I did that one wrong. That should be 3. This is 4. Okay, the points have equal x and y coordinates. Well, remember in quadrant 1, we were positive, positive. In quadrant 2, we are negative x, positive y. Quadrant 3, we are negative, negative. In quadrant 4, we are positive x, negative y. So the only places where they can be the same, look at it. Where can they only be the same? Only in quadrant 1 and quadrant 3, because they're either positive and positive or negative and negative. So we're going to look in those two, and let's see. Point A right here, what point would that be? Well, we count over 1, 2, 3 in the x, 1, 2, 3 in the y. That's point 3, 3. And look at point D. Interesting. That's 1, 2, and 1, 2. So that's point 2, 2. So those points both are equal x and y coordinates. So A and D. And let's look in quadrant 3 as well. Look at C. C is at negative 1, negative 1. So C fits that criteria. And then 1, 2, 3. Or sorry, if we count the origin, we count left 1, 2, 3, and then down 1, 2, 3. We end up at B. So B is at negative 3, negative 3. And that also fits. So A, D, C, and B. A, B, C, and D all fit that. Okay, final question. The points that have opposite x and y coordinates. Where are they opposites? Well, we are only opposites in quadrants 2 and quadrants 4. So let's see which ones have exact opposites. What is point J? Well, point J, if we start at the origin, we count over to the left 2, so we're at negative 2 in the x, and then up 2, so that's positive 2 in the y. So negative 2, negative 2. Those would be opposites, so J fits that criteria. Let's look at K there. K we would count over from the origin, 1, 2, 3, 4, and then up 1, 2, 3. So that's at negative 4, 3. Are those opposites? No, they're not opposites. So, I mean, they're opposite signs, but they're not exact opposite values or opposite coordinates. So that's all from quadrant 2. Let's look at quadrant 4. Let's count to the right. We'll start at the origin. We'll go to H. We'll count over 1, 2. So it's positive 2 in the x, and then down 1, 2, down 2 in the y. So 2, negative 2, they are opposite. So we have point H also, and let's check out point P finally. Let's count to point P from the origin. Let's start at the origin and count to the right, 1, 2, 3, and then down 1, 2, 3. So that is at point 3 in the x, negative 3 in the y, and those are in fact opposite. So point P also have opposite x and y coordinates. All right, you should be well on your way to plotting some points here. So put that pen in your hand, take some great notes, have this all ready to go, and we will discuss this soon, and you will be a master. Yay, math!